So right here is the simple application we're going to be building. We basically have an API endpoint, or you can just think of it as a route that returns a JSON response. And what this does is to basically return this simple message of this takes long, but the idea is the user should be in position to get a response very fast without having to wait for that task to be executed. So I can delay this by a certain amount of seconds. So let me start with one that takes a very short amount of time. Let's not even provide a query param. So that's a task that's supposed to take only 2 seconds because I set that as the default. But what happens if we add some task that, let's say, takes 30 seconds? That will be still queued and the user will be in position to get a response. So we can also add, let's say, 350 seconds and the user will still get their response in a very short amount of time. Now the purpose for this is to just demonstrate how we can set up Celery with Django through Docker Compose. Now we have a dashboard right here, which is our Flower dashboard. This is going to allow us to be in position to view different things about Celery, such as the worker, the status of the worker, how many of the tasks we have that are running. So when you go to our task section, we'll see the different tasks that are currently being executed. So for as long as the task is executed, it will execute, and then the other task that came before it is the one that will be executed next. So we have that order of fast in, fast out. So that is exactly what is going to happen right here. So yeah, we have our Django admin dashboard right here. So this is what is making use of the PostgreSQL database that we've also added. For a much more clear setup, I'll go to Docker desktop and show you everything. So these are the logs for our Flower dashboard. But if we were to go back here, we have, this is like the entire stack, or the entire Compose stack that has the different containers. We have Redis, we have the PostgreSQL database, we have Flower, we have the Celery worker, we have our Django app as a service of its own. We can view the details by simply navigating to the individual service. So this is our GUnicorn Django application. So Django is running, GUnicorn is the one that is running the Django app as the web server. We have our Celery workers running here. So these are the logs, some of the tasks that are being executed. We can go back here and then try to also see the database logs. So these are the PostgreSQL logs, and then we can be also able to see our Redis. So yeah, that's the kind of setup we're going to be setting up in this video, and let's get started. To follow along with this video, you're going to need to have the following installed. You'll need a Python installation on your machine, because that's what we're going to be using to create a virtual environment. We're also going to need to have Docker Desktop. Now, installing Docker Desktop will give you access to almost everything you'll need. In fact, all you'll need is Docker Desktop. It will give you access to Docker and Docker Compose, and you'll be good to go. So the first thing we're going to do is to go ahead and first of all set up a virtual environment. Why? Because we need to keep track of the packages or dependencies that our application is going to be using. So to do that, I'm going to go to my VS Code right here. I have a description of what we're going to be setting up right here. So let me first of all close that, and we first set up our simple application. So I'm going to open up a terminal right here. I'll create a virtual environment with Python -m venv env. Now please feel free to use whatever tool you may want. You may use UV or pipenv, but I'm going to keep it to venv. Once our virtual environment has been created, the next thing we're going to do is to activate it with source env. So I'm on Windows, so scripts activate will be the way to activate it. However, on Linux, it will be something like env bin activate. Once that is done, then we're going to install our requirements. So we're going to be installing Django with pip install Django. And we're also going to install python.env because it's what is going to allow us to read our environment variables. Another thing we're going to be installing is Celery, because we're going to be setting up background workers. So we're going to be setting up Celery, but we want to use Redis as our broker. So I'm going to add the Redis Once that is done, I'll also add the cycle pg2, which is the PostgreSQL driver for the database. So I'll add cycle pg2 binary, and that will act as our PostgreSQL driver for Python. Now, once I've installed these, I'm also going to add GUnicorn because that's the server that we shall use to run our app within our Docker container. Once that is done, I'll press enter, and then we'll go ahead and install those requirements within our virtual environment. Now that our requirements have been installed, let us go ahead and pip freeze these to our requirements.txt file. So I'll do pip freeze, then I'll pipe requirements but text. So that will create the requirements.txt file with all the requirements that we're going to need for our simple project. So once that is done, now we can go ahead and access the Django admin command that will help us to create our Django project. So to start, I'll say Django admin, and I'll then go ahead and start a project. Now I'll call the project folder core, and then I'll specify that this is going to be within our root project folder, because what we need is to have the money.py file external, the project folder. So once that has been done, we now have money.py. Outside here, we have the project folder right here. Now, one thing to note is this file. So this demo.txt is a file I created to kind of explain what we're going to be setting up. So we're going to be setting up our Django app, which we have actually created right here. We have our DB, which is going to be the PostgreSQL service. We also have a Celery worker that we're going to be adding to this setup. Now, this Celery worker is going to be making use of Redis as the broker or the transport through which messages will be sent from our Django app to Celery. Then we shall also set up a monitoring dashboard that is going to be Flower, that will look at Redis and help us show us the messages or the tasks that are being performed. It will also help us to view things such as the statuses of those tasks and so on. So I'm going to close that, and when I go back right here, we're now going to run our simple Django app. So I've installed GUnicorn, but GUnicorn does not work on Windows, so we shouldn't expect it to work. What I'm going to do is to just run it normally with Python, money.py, run sub. So when I run that, our server will start and we'll open it up on localhost 8000, just like you see right here. So we've successfully set up our single Django app. Now the next thing we're going to do is to create sort of like a simple view. So I'm going to create a simple view right here. The first thing I'll have to do is to go ahead and first of all create an app. So I'll say Python money.py start app, and then I'll call this app test app. So this is what we're going to be using for our testing and testing the background workers. So once we've done this, the next thing is to register that in our settings.py. So once I've opened up this, I'll then look for the installed apps list where I'm going to add the test app application. So I'll go ahead and add it. So this will be test app.apps test app config. And if you're wondering where that class is located inside the test app, and then inside apps.py we have that class called test app config. So that is what I'm adding to our install apps list. Once I'm done with that, I'll create a simple view inside our test apps. I'll come right here and then define a view. So I'll say return. Let me just call this return long, or let me just define it as long running task. So this will take in a request object, and then it will return some sort of like JSON response. So for us to return a JSON response, we'll have to import the Django HTTP JSON response class. So I'll come right here and I'll create a response. I'll say return. Sorry for that. So this will be returned. And in this case, we shall have JSON response. Then we shall have our data as a simple message with the value of this takes long. So we're going to be writing some code for a task that may take long, and we'll look at how we can basically queue that within Celery. So once this is done, we're now going to go ahead and register this to a URL. So I'm going to go within the app, and then I will create a urls.py file. Running. So we need to register these URLs to be accessed on our project. So what I'll do is to go to our project level URLs. So that's the core URLs. And then I'll have to go ahead and import a function called include. And then I'll add that here. So I'll say path inline. So our root URLs will be including the URLs we define in our test app. So that will be include test app.urls. So once that is done, I'm going to get rid of this name because we don't need it. And that will be just enough for us to have our endpoint or our simple JSON route. So I'll run our server with Python or python3manage.py run server, and that will start our server and expose our port or run our server on port 8000. So if I go back here and refresh, we now see that response is taking long, but it basically returns the message or the JSON response of this takes long. So now we've successfully set up our simple application. Now we're going to be setting up things, and we're going to be setting up PostgreSQL first, and then we shall add Celery and the rest of the other components. So to begin, we're going to first of all containerize this simple application. And to do that, we're going to need some sort of Docker file. Now, a Docker file is simply a file that's going to explain the instructions that are going to be needed to set up an image. Now, think of an image as a zip file, as a small zip file in which all that is needed for a container to run is going to be contained. Now, you can think of a container as a process that is going to run the application through the image. And I'm going to be showing how that is going to run. Now, what I'm going to do, since I have very many components and I'm going to end up with very many Docker files, I'm going to create a folder here, which I'm going to call Docker files. And this Docker files folder is going to contain folders or directories in which I'm going to have the different components. So I'm going to have the app Docker file located inside Docker files app. And I'll create a new file right here, and I'll call this the Docker file. So this Docker file is going to be specific to our Django app. Now, the process of creating a Docker file for a Python app is going to be very similar. What you need to first do is to, first of all, build from a base image. And in this case, we need to point to a specific Python version or a specific Python image. What I'm going to be using is a Python 3.13 slim image. I've actually written this wrong. So the name of the image is Python, but the tag that points to the specific version is going to be 3.13 slim. And that's exactly what I'm going to be using. Next, I'm going to create a work directory, which is going to be where our code is going to reside and run from. So that's going to be the /app directory. Once that is done, then I need to copy the requirements.txt file inside the container file system. So I'll do that with requirements.txt to dot. So what this means is we are copying the requirements.txt that we've created right here into our image, and that will go ahead and copy it. The reason that's why we're doing this is because we want to have that requirements.txt file help us to install the requirements before we actually set up our source code. And once that is done, we shall now run pip install. So shall go ahead and run pip install requirements. So we need to point to our requirements.txt file with -r, but we can also go ahead and specify other commands right here or other options. So I'll say no cache there. Another thing is that sometimes there are going to be some environment variables you need to set. So those are going to be set up with env. So you may do something like Python don't write bytecode, and then you set that to 1. So that is basically an environment variable. Now you may also set up Python unbuffered and the rest of those, but I'm going to keep it simple so that we can just run pip install requirements.txt. So I'll just run that exactly. Once that is done, we now need to copy the rest of the code to our container or our image. So copy ... will mean we're going to copy everything to our image. Now, one thing we need to do also is to make sure that we ignore some files. So I'm going to create a root file, which I'm going to call .docker ignore. You can think of this as your git ignore, but in this case, it's the docker ignore. What it does is to just prevent some files from entering the image. So that's exactly what we're going to be doing. Now, here we're going to add our env folder, which is going to be our virtual environment. Some will even call it dev, but feel free to add whatever name that here. We're also going to be ignoring the db.sqlite3. Actually, we're not going to even be using it since we're going to be using Postgres. Another thing we're going to ignore is going to be maybe the file demo.txt. So that is going to be left out as well. So we shall be having core, Docker files, maybe money.py and requirements.txt inside there. So once that is done, the next thing is going to be to then expose some ports. So we may expose the port 8004 for our app to run on that. And then we need to use GeoNicon, which we have set up as our web server to run our application. So before we do that, we can also go ahead and set up GeoNicon to basically have some settings that is going to use to run the application. Now, the thing is, GeoNicon will read from very many places, but it will also read from a GeoNicon conf.py file. So the GeoNicon conf.py file is going to be the default file or the configuration Python file it will read from before it actually runs. It will check environment variables, check for the GeoNicon conf files, and then it will be in position to pick configurations. Then it will run the application. So before we actually set up the command, what I'm going to be doing is to create a geonicon.conf file. So I'll create it at the root project folder because that's where GeoNicon will be running from. I'll say this is going to be geonicon.conf.py, which is going to be a Python file. Then inside here, we can specify arguments or configurations like bind. So this is going to be the IP address on which the server is going to run. It's going to be using 0.0.0 and then port 8004 because that's the port on which you want to run the app. Now we can also go ahead and specify things like the workers. So what worker processes will run the app. So we can maybe put this to 4 or put this to whatever number depending on your needs. Now we can also specify things such as the worker class and so on. But I'm simply going to leave it here and leave it to have these two settings. And once that is done, we can now run our GeoNicon. So I'm going to be using the command, and then this takes in an array of a command and its arguments. So this is going to be making use of GeoNicon. Let me put this in lowercase. So put this in lowercase with VS Code, and then I will point to the name of the app we want to run. So in most cases, it's going to point to the WSGI. Actually, it's going to point to the WSGI application, in which our application in Django is going to be in the project folder in the wizgi.py file. So inside there, we also have this application variable, which is going to be the wizgi or the WSGI application instance. So that's what we need. So what I'm going to be doing is to point to that. So that's going to be core.wizgi. Then sometimes people specify the name of the exact application instance, which is going to be application. So that is just enough for us to have our application running inside a container. So to create an image out of this, what we're going to do is to build using this Docker file. Now, since I'm using git bash, I'm not going to be running those commands in here because I tried it and I was getting errors of something that has to do with platform architecture. So what I'll do is to pull up a PowerShell window. I'll press Ctrl and R on Windows, and then I will run PowerShell. So this will open up a PowerShell window right here. And in this PowerShell window, I'll then navigate to my document. So let me make this bigger for you guys to see. So I'm going to navigate to documents. And then inside documents, I'll navigate to our folder, which is the Celery, Redis, Django, PostgreSQL project. So inside here is where we have all these files, just like we've created them, the project folder, the Docker files, and the rest of the files. Now, for us to go ahead and build an image, we'll do that with Docker build. Then we specify the name and the tag of the image. So in this case, I'll just call this simple Django app. And then I will provide the file that I want Docker to use as the one that's going to build the image from. So that is done via the -f flag or the -f option. So the file is going to be located inside Docker files, and then we shall have app and then Docker file. And once that is done, then I need to specify the context or where this is all going to happen. So that can be done with dot. So this command is basically pointing to the tag, or it's going to build the image, but it's going to provide the tag that we've specified right here. And it's also going to be making use of the Docker file that we've pointed Docker to via the F option. So when I press enter, this will go ahead and build an image from our Docker file. So to run all the steps that we've defined within our Docker file. And in this case, we see that it will first of all load from the base image, and then it will create the workdir, and then it will copy our requirements. So txt install our requirements. And once that is done, it will go ahead and run or copy our files. After copying the files, it will then proceed to run our command or create an image that's going to be using our command to run our container. So let's wait till this is done. It will all depend on our internet. All right. Now that our image has been created, we can even verify that by using Docker desktop. We can run the command, we can use the command docker image ls to show our image, which is the simple Django app. However, we can also use Docker desktop by going to the images, and then you'll see our simple Django app. And this is the detailed way that Docker desktop or Docker is creating the image for us. So these are what they call the layers. So every step is what will actually lead to the creation of the image that we've created. So now that we've created our image, we have to run a container out of this image. Doing that is as simple as pressing the button right here, but we're going to be doing that with the command line. So inside our command line, we're going to go ahead and run the image by using docker run. So this will create a container process from the image we've created. So a container process is going to be a process in the Docker that is going to be running our application. So in this case, we need to point to the name of the image we want to run. So that's going to be our simple Django app. And to be specific, we can even provide the name of the tag we used. Now, I don't know if we used that tag, but when I look at here, we only have latest as the name of the tag. So if we built our image with, let's say, a specific version, let's say simple Django app version 1, that would be the tag that would specify. So if I went right here and provided latest, that would be the default tag. Then that will run our container. So I think this is simple app, single Django app. So I'll go ahead and run that. So that will run our server with GUnicon, just like you see right there. And this is working the way we want because all the commands have been specified inside, or all the settings have been specified inside our GUnicon.conf.py file. So it will read this file and then it will run the server based on what we've specified in there. So let's make a brief recap of what we've so far done. What we did is to set up our Django project, which is our core folder here. We created an app. We added a simple URL into that app. And now we have gone ahead and created a Docker file to basically help Docker create an image. From the image, we've now run the container, which is now running. So let us try to access this on our local machine. I'll do that with Control and click. But right now we see that we cannot access anything on that IP address. So let's try to go to localhost 8004. We still see that we cannot be in position to see our application running on that port. Now the reason for that is because whenever we run a container inside Docker, that container is not exposed to our external networks. So our host machine, which is our Windows machine for this video, is not that in knowledge of the networking of the simple Django app container that we are running. So for that to work, we need to do some sort of like port mapping. And to do that, we're going to run the same command, but before we specify the image from which we're going to run, we're now going to add this -p flag, which is going to be specifying the ports on which we want to run this app. Now we want to map the port that we exposed inside our Docker file, which is port 8004, to the port 8004 of our machine. And the way we do that is by running 8004 colon 8004. Once that is done, I'll press enter, and now we see our server is then running again. So this time, if we try to access localhost 8004, we shall then be in position to access our application. So this is our endpoint, and it has the message, this takes long. And even if we go in our logs right here, we can see that we are now having some success. We are now in position to make some requests to our server. To check what is happening, we can run a Docker logs. So in this case, we can run Docker logs, and then we can point to the name of the container. So let's first do a Docker container ls to show the containers that are running. So this is the simple Django app. So we can now copy the first 4 or the first 5 unique characters from the name or the ID of the container, and then we can come right in here and say Docker container or Docker logs directly. So we can do Docker logs, then we specify the container ID. So this will show us what is being logged from the container itself, and now we see that our server is running and everything is working successfully. So I'll clear that. So yeah, we are currently running our server, and that is beautiful. So that means one component is actually done. Now, to make things a little bit more interesting, what we're going to be doing is to add a PostgreSQL database onto our simple app. And the way we're going to be doing that is through Docker Compose, a tool that's part of the Docker ecosystem that allows us to run multiple containers. It helps us to orchestrate those containers and enable them to run together smoothly. And let's go ahead and look at how we set that up.